Christopher McKay published a survival framework for the Red Planet. Their strategy relies on manufacturing what we need on site, rather than bringing a constant supply from Earth. The first step is securing a water supply by drilling directly into the crust to extract subsurface ice. Next, we tackle the atmosphere. By feeding local carbon dioxide into a chemical reactor, we split the molecules, stripping the carbon away to generate breathable oxygen. Even with local water and air, colonists have a strict packing list: shielded habitats to block solar radiation, and closed-loop life support systems that recycle every drop of moisture. Mars proves that long-term survival relies on engineering the missing pieces of Earth, rather than finding a planet that already has them. If we look past the rocky inner planets, our options shift to the massive frozen satellites orbiting our solar system's gas giants. Saturn's largest moon, Titan, remains wrapped in a thick, opaque smog of nitrogen and methane that entirely hides its surface. Then there is Jupiter's moon, Europa. On the outside, it is a completely frozen, irradiated shell, but planetary scientists look at these deep reddish cracks intersecting across the ice sheet as evidence of a massive, shifting liquid ocean hidden miles beneath the crust. Earth's marine ecosystems largely run on sunlight. Europa's ocean, locked under thick ice, would have to be heated from within by geothermal vents operating entirely in the dark. Titan and Europa expand our definition of where biology can take hold. They show that the basic ingredients for life can persist in the darkest, coldest corners of the solar system. To find a true mathematical match for Earth, we have to look thousands of light years away, settling our focus on an exoplanet called Kepler 452b. It is remarkably close to our planet's size, and it orbits its own sun-like star within the habitable zone, where liquid water could pool on its surface. Because Kepler 452b is roughly 1.5 billion years older than Earth, it has a much longer window for advanced civilizations to have evolved. Researchers at the SETI Institute use the Allen Telescope Array to scan this world. They point to a collection of 42 radio antennas at the planet, listening for artificial broadcasts. Kepler 452b represents an expansion of our search, moving from planetary habitability to a search for active communication. Our cosmic real estate portfolio is diverse. We are testing our engineering limits on the dusty surface of Mars, scanning the frozen oceans of Europa, and analyzing the ancient potential of Kepler 452b. When we measure these alien environments against our biological needs, we face the distinct possibility that some distant worlds possess conditions better suited for long-term life than our current home. The hunt for a second home has evolved into a methodical, active scientific pursuit across global observatories and laboratories. Whether we are figuring out how to generate oxygen in the red dirt of Mars or listening to the silent static of deep space, every step we take today builds the foundational knowledge required to one day